Okay, we're going to continue talking about distance and displacement. We're going to start with this example. Okay, I have a bird flying 6 miles north and 4 miles east, and I want to know its distance and displacement. So I'm going to make a sketch here. I'm going to pick a spot to be my origin. Okay, I'm going to draw in north, south, east, west. Okay. Now, from his origin, he goes 6 miles north. And turns, he goes 4 miles east. All right. Now, the distance is going to be pretty easy, because for distance, I don't worry about direction. For distance, all I say is he went 6 miles and he went 4 miles. How far did he walk together? The distance is going to be 6 miles plus 4 miles. And that's going to equal 10 miles. So that's pretty straightforward. However, the displacement is going to be trickier. Displacement is where he is relative to his initial position. So here's his initial position. I'm going to draw in an arrow, a vector representing that displacement. It has to start at the origin and end where he ends up. Because he's northeast of where he started, the arrow has to point northeast. And I'm going to label that the resultant displacement. Now, I have to find out how long that is first off. And it's going to be easy in this situation because north and east meet at right angles, so that's a right angle there. And I'm looking for the hypotenuse of this right triangle. In order to find that, I can just use the Pythagorean theorem. So my resultant displacement is what I'm trying to find. Let's say delta x squared is a squared plus b squared. X squared is 6 squared plus 4 squared. If I put that in my calculator, add them up and take the square root, I'll end up with delta x is 7.2 miles. Now, I'm not done yet, though, because displacement is a vector, so I have to give direction. And before I use the term northeast, but this isn't exactly northeast. Northeast means exactly evenly split between north and east. This is a little bit more north of that because the 6 miles is bigger than 4 miles. So a little more north than east. So what I have to do is tell an angle. And that's why I drew in this little axis down here. I'm going to tell the angle relative to east and west. So I want to find that angle right there. I'm going to label that angle theta. Okay, in order to find that, I'm going to look at this triangle here. And I know this side of it is 6, this side of it is 4. And how am I going to find it? I'm going to have to do a little bit of trig. If I look at that angle, this 6 we call the opposite side, because it's across the triangle from it. The 4 is the adjacent side, okay, because it's next to it. Okay, and then this resultant is the hypotenuse. Now, I'm going to use tan for this because we remember our trig. Remember the trig functions by SOHCAHTOA. Okay, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and so on. And I have my opposite here, I have my adjacent here. So the one with opposite and adjacent is tan. So I'm going to use tan theta is opposite over adjacent. Now, that's going to tell me tan of theta is the opposite side is 6, the adjacent side is 4. Solve that in my calculator, I do 6 divided by 4, and then do inverse tan. When I do that, I end up with a theta of 56.3 degrees. Okay? And then I have to say where it is. Well, my reference line was this east, and I swung north of there. So north of east. So my entire answer for the displacement is delta x is 7.2 miles at 56.3 degrees north of east. Okay, at the top of the next page, we're going to kind of do the same problem backwards. A plane flies 300 miles at an angle of 40 degrees north of west. We want to know how far north of its original position is it and how far west. So I'm going to sketch this in here. My plane is going 300 miles at an angle of 40 degrees north of west. So I'm going to put in my little axes here. Okay, 40 degrees north of west means that it's going off this way. And this is 40 degrees because west is my reference in this case, and I'm swinging 40 degrees north of it. I'm going to say this is 300 miles. And I'm going to let D say for displacement. Now, I want to know how far north and how far west. What I'm going to do is draw in what's called the components of this vector. Okay? If I added this one, which I'm going to call dx, this one, which I call dy, I'm going to end up getting that result. So always draw out in the x direction and then up or down in the y direction to find the resultants. So, now I have to figure out how big they are. And again, we're going to use some trig. So if I look at my 40-degree angle here, the x, the dx, is the adjacent side because it's next to the 40. The y is the opposite side, and the d is the hypotenuse. Now, I can do so again. Okay. Now, I'm doing this out in gory detail. Okay, you don't have to show all these steps. You don't have to write out SOHCAHTOA every time. But if it helps you to do it, if you're not that great at doing trig quickly, go ahead and do all the steps. So I can say sine of theta is opposite over hypotenuse. Okay, my opposite side is dy, so I'm going to get sine 40, because that's the angle, is dy over hypotenuse is 300. Then I can cross multiply, and I would get dy is 300 sine 40. So dy ends up being 192.8 miles. Okay. Now, that is called a y component. Okay, we could also call it the northward. Now we're going to try to find x. So x is the adjacent, and I have the hypotenuse, so I want the adjacent hypotenuse, so I'm going to use cosine. So cosine theta is adjacent hypotenuse. So cosine of 40 equals dx over 300. And then dx is going to equal 300 cosine 40. So then we get dx equals 229.8 miles. That's the negative sign in front of it. So if I think of it, x is usually going to the right. This dx is pointing to the left. So I'm going to make it negative. And I could call that the x component. So that's a lesson on finding the result of two vectors that are meeting at right angles, or finding components of a vector, which are the x and y pieces of that vector.